Now, what do we need to do? We must have our acceleration. We cannot answer this question. We cannot answer this question if we do not have our acceleration. So the first step that we do when we calculate, we will say F net, because already we have a mass. F net is equals to MA, and our mass is 0,2. And remember, we are now calculating acceleration because now we cannot use 9.8 because there is a force that is being added, that is being exert on the floor. Then the magnitude of the force is 50. Then, now, when we remember the Newton's second law, we have this thing with the Newton's second law, whereby you must be able to identify the forces acting on an object. So we have the force that is being exerted on the ball, the force of the floor on the ball, and also we have Fg that is always there. These two forces are doing the work. So the net force, our net force, it is the sum of these two forces, which is the force on the floor, the force exerted by the floor on the ball, plus Fg. I'm sorry for that. Now, Fg, our Fg will be Fg is equals to mg, whereby mass is 0,2 times 9.8. This equation, it is also given on the table of formulae. Now, you will do your mathematics. You have 50 and also 0,2 multiplied by 9,8. But when you look at this first diagram that I just drew, you must be able to notice that these two forces are in opposite direction. So let's make Fg positive and also force exerted by the floor on the ball be negative. Then after doing a calculation, your acceleration will be equals to minus 240,2 meters per second squared. But now, because we have acceleration is a vector quantity, you must not leave your answer as negative, but it must be positive. Then from there, we go back to our acceleration, our time. Now we have our acceleration, then we can choose the equation. So when we look at the first equation, we do have our final velocity, we have our initial velocity, we have our acceleration. Then we can use this first equation to calculate delta t. So Vf is equals to Vi plus A delta t, whereby Vf is equals to, remember I said to you, the ball bounces off with a magnitude of 3.43 meters. So Vf will now be 3.4 meters. But now it is moving upward. And also, this one, it was moving downward. The initial velocity is now 3.96. So we will take positive as downward first, and then we will do it as negative downward again. Now, if positive is downward, which means our final velocity will be minus 3,43. Remember, I said to you, when you substitute, do not include the unit, and also the initial velocity is 3,96 plus. Now, when you substitute, when you use the magnitude that was calculated before, and then here we changed the signs, you are not going to use this one, but we are going to take this one where it is, acceleration is negative. So it's going to be negative 240.2 times delta t. Therefore, it is equal to, our delta t with the calculator will be 0,03 seconds. That's how we calculate our delta t. Boys and girls, what is important here is I just want to repeat this statement again. Because of this force, there is no way we will say on the ground, there's no way we will say on the ground the ball was in a free fall state because of that force. And what I like about the examiners, they will give you the magnitude. And I just want to assure you that if you are given the magnitude and you did not use that magnitude, know that your answer is wrong. Everything that is given, it means it must be used. Now, let's move on to the next question. It says, the ball takes 0.404 seconds from the moment it is dropped until it strikes the floor. Sketch a graph not to scale, a position versus time representing the entire motion of the ball. Use the ground as zero reference. Now, you know what I like? Every time when you are given a question, the words that are capitalized might be keywords. So you must take them into consideration, all the words that are being capitalized. Now, they say, when you sketch the graph, indicate the following. 1, the height from which the ball is dropped. Number 2, the height reached by the ball after the bounces. Number 3, time at which the ball bounces off the floor. So all those things must be indicated. The first thing that you do is so simple. You just write position, time graph. That is the first thing that you do. And then you draw your graph. Guys, remember the direction that you chose from the beginning. The graph that you're going to draw must be a positive upward or positive downward. Now let's start with positive downward. We are drawing the position time graph. Then our position time graph must have the axis, and also here it is position in meters. So when you draw the position time graph, do not forget that you only concentrate on the height or the displacement. Forget about the velocity that was given, because you are not requested to calculate the velocity time graph. So you only concentrate on the height. And on this case, we were given two heights. We were given the height 0.8 meters when the ball was dropped, and also after it bounces, the maximum height was 0.6 meters. And on the question, you were asked to indicate the height from which the ball is dropped, which is 0.8, and also the height reached by the ball after the bounce, which is 0.6, and also the time. So we have 2 times. Now, let's start. At this point, we have 0. Then 0.6 is less than 0.8. You must indicate. And also, the ball was dropped from 0.8. Then when it reaches the ground, it has the time of 0.404. You were given that time. Here it is, the time that I'm talking about. And also, it bounced off. And then when it bounces off, it reaches the maximum height of 0.6 meters. Then when it bounces off, the time was, remember, we calculated the time and then we found it as 0.03 seconds. This one. Then we're just going to add this 0.404. We're going to add plus 0.03. So the answer will be 0.4. The second time will be 0.434 seconds. So this time, it is this one. I'm sorry for that, because now we have, and then that was our last question. Now, what we need to do is to take a break of 10 minutes, and then when we come back, you will forward your questions at 07674222529, and then I will answer them immediately after I'm done with Newton's second law of motion. Then When we come back, we're going to start with Newton's second law of motion.